Next question number 71. Which of the following molecule is linear? Now in this, among these four options, we need to find the molecule which is linear. See, you can go by the formula for the hybridization of the central metal atom. See, NO plus is linear, but I'll do for every molecule for you. See, this is a neutral molecule. Now, for neutral molecular formula is equal to S is equal to 1 by 2 times of number of valence electrons plus monovalent atoms, right? Yes. Now calculate the S value for SO2. S is the steric number. 1 by 2 times of number of valence electrons in sulfur is 6 plus monovalent atoms are 0. So that is coming to be 3. So sp2 hybridization. So sp2 means trigonal planar. Trigonal planar. Okay. So let me use a different kind of pen. Yes. Now the same thing you can do for NO2 plus but this is an ion. For ion the formula will be S is equal to steric number is equal to 1 by 2 times of valence electrons plus monovalent atoms minus the charge magnitude. Why minus? See, I have told that in the previous classes. I explained that if it is a positive charge, you need to subtract the magnitude of the charge, right? Yes. Now apply it. So S is equal to 1 by 2 times of valence electrons in nitrogen is 5 plus monovalent atoms. So there is no monovalent atoms, 0. Now the charge is 1 unit positive charge, so minus 1. Now 5 minus 1, 4. 4 by 2 is 2. So it is sp hybridization. When the steric number is saying 2, then it is sp hybridization. That means you are going to have a linear structure. Linear. So that is our answer. You can follow the same procedure for the charged species and the neutral molecule like this. See, this is anion. For the anion, what you need to do in the place in this formula, you need to add the C plus C. For anion plus C, for cation minus C. Okay, yes. Question number 72. The geometry of the molecule with sp3d2 hybridization atom. See, when it is sp3d2, how many atomic orbitals involved? 6. When there is 6, it is octahedral. Octahedral. It suggests that octahedral geometry. Third option is the best option, correct option. Now question number 73. The single, double and triple bond lengths of carbon in carbon dioxide are respectively. See, you know that single bond length is more than double bond and double bond length is. So we need to find single, double, triple. So double is more than triple like that. Single, double, triple. That will be the best answer. Next question number 74. The shape of boron trifluoride molecule is again same concept. S is equal to 1 by 2 times of valence electrons in boron is 3 plus monovalent atoms 3. 6 by 2, 3. It is sp2 hybridization trigonal planar. Next, moving towards question number 75, I hope you are following very clearly. Which of the following pairs has the same structure? See, we have been given 4 options. Among these 4 options, we have to pick that option in which a pair is there and that pair has the same structure. See, this is PH3 and BCl3. BCl3 is trigonal. It is trigonal planar. This is tetrahedral. This is angular. This is tetrahedral. Or sorry, it is pyramidal. This is trigonal pyramidal. Okay. This is angular. this is angular, V shape. This is a tetrahedral, this also tetrahedral. So, the pair which is having same structure I is the fourth option. What happens to this? This is octahedral and this is a trigonal bipyramidal. So, fourth option is our answer. Okay. Next question number 76. Which of the following is not linear? Not linear. Of course, CO2 is linear. And if you remember how to draw the Lewis dot structure, then you will know that I3 minus is not linear. So, obviously none of this. So, CO2 is linear, I3 minus is linear. So, ClO2 is not linear. Next question number 77. As the S character of hybridization orbital increases, it's not hybridization orbital, it is hybrid orbital. As the S character of hybrid orbital increases, then the bond angle. See, we discussed all sp3, sp2 and sp. Here S character is 25%, here 33.33%, here 50%, and the bond angles are 109 degrees, here 120 degrees, here 180 degrees. So, it means that as the S character increases, bond angle also increases. Okay? Yes. Next question number 78. The shape of IF7 molecule. See, IF7 molecule. Here the point is, it is a neutral molecule. Calculate steric number. S is equal to 1/2 times of number of valence electrons in halogen, iodine is 7 plus 7 monovalent atoms. So, 14/2, it is 7. So, the hybridization is sp3d3 and the geometry suggested for this hybridization will be pentagonal bipyramidal. Pentagonal bipyramidal. That's it. And question number 79. Which has sp3 hybridization of central atom? Of course, PCl3. So, draw the structure or determine the hybridization by using the steric number formula. Yes. Next, which of the following is correct set with respect to the molecule hybridization and shape? Okay, BeCl2 is sp, not sp2. This is wrong. BeCl2 sp2 trigonal planar. That is correct. BeCl3 sp2 trigonal planar. Wait. BeCl2 sp. So, this is also wrong. BeCl3 sp2 trigonal planar. That is correct. BeCl3 not sp3. Yes. Next, question number 81. Which of the following compounds does not have linear structure? Yes, carbon dioxide is having linear structure. Acetylene is linear. BeCl2 linear. Of course, SO2 is a trigonal planar. That is our answer. Question number 82. The percentage of S character of hybrid orbitals in methane, ethene, and of course, this kind of question we did already. Methane, ethene, and ethane. So, obviously sp3, sp2, sp. So, percentage increases. The percentage here is 25%, here 33.33 and 50%. We already came across these kind of questions. And question number 83. The molecule which is pyramidal in shape. See, this is the geometry is the electron geometry is a tetrahedral, but the molecule is pyramidal. The shape is pyramidal. This is a trigonal planar. This is trigonal planar. Of course, this also. This is only pyramidal. Moving towards question number 84. I hope you are following carefully. Which of the following has a linear structure? Again, same kind of question. Tetrahedral, this one. Trigonal planar. This is also trigonal planar, and this is linear. C triple bond C H H linear. Next, sp3d2 hybrid orbitals are sp3d2, that is octahedral. Very direct question. Yes. The hybridization in boron trifluoride molecule is, the hybridization in boron trifluoride molecule is sp2 BF3. You can do by the formula BF3 like this. Yes. Next, among the compounds boron trifluoride, NCl3, H2S, SF4 and BeCl2, identify the one in which the central atom has the shape, central atom has the same type of hybridization. See, BF3 is sp2, this is sp3. So, this is not our answer. Again, BF3 answer, not our answer. This is sp3 and this is both are sp3. Both are sp3. Yes. This is beryllium is having sp hybridization. This is sp3. And this is the sp3d hybridization we already did for a previous question. This is sp. So, our answer is E option. Next, question number 88. The molecule of carbon dioxide has 180 bond angle. It can be explained on the basis of, yes, sp hybridization. Carbon dioxide is linear because the central atom undergoes sp hybridization. That's why the bond angle 180. That's why this bond angle 180 degrees. Next, sp3 hybridization is found in sp3 ammonia, right? And here sp2, here sp2, here sp2. Next, question number 90. Which set of hybridization is correct for the following? So, we have been given with NO2, SF4 and PF6, PF6 negative. See, NO2 is a odd electron molecule. NO2, nitrogen dioxide, is a odd electron molecule, and that means it is going to have odd number of electrons. How, sir? See, in the valence shell of nitrogen there is 5 electrons, 1, 2, 3, 4, 5. So, I will write in a different way. Nitrogen 1, 2, 3, 4, 5. See, double bond oxygen, and you can have double bond oxygen like this. This is the electron, odd electron. So, when you count the steric number, count this odd number of electrons. That is, so, sigma, sigma. So, in this double bond 1 sigma, in this double bond 1 sigma, 2 sigma plus 1 odd electron also be counted. So, total of 3, total of 3. So, steric number coming to be 3, sp2 hybridization. So, yeah, this is sp2, and after that SF4 we already determined it is sp3d in the previous question, and it is PF6 negative. See, PF5 means sp3d, PF6 means steric number coming to be 6, so sp3d2. So, the first one sp2, sp3d and sp3d2. sp2, this is not correct. sp3 not correct, and sp3d and sp3d2 correct. So, I think it is the print mistake. So, considering these two, I am going with this option. So, NO2 is sp2 hybridization, NO2. It is sp2 hybridized, nitrogen sp2 hybridization. The state of hybridization of boron in BCl3, of course sp2, yes. The hybrid state of sulfur in SO3, we already came across this. I already explained. So, the steric number coming to be 3. Valence electrons. Which of the following molecule has a pyramidal shape? Of course, PCl3. So many times PCl3, this is the pyramidal shape. The hybridization of IF7, you can go by the formula S is equal to 1 by 2 times of iodine valence electron 7 plus 7, right? So, that is going to be 14 by 2, that is 7. So, the suggested hybridization is sp3d3, sp3d3, the first option. Moving towards question number 95. Geometry of ammonia molecule and the hybridization of nitrogen. Geometry is hybridization sp3 and tetrahedral geometry, that's the correct. sp3 hybridization and distorted, no. sp2, no, none of these, no, yes. Which of the following is a non-linear molecule? These kind of so many questions we got this kind, right? BeCl2 linear, CO2 linear, CS2 linear, C double bond O. Similarly, C double bond S double bond S. See, oxygen and sulfur same family, you can draw like this. And we know very well BeCl2. It is a linear molecule, no doubt about it. Only carbon dioxide, see CO3 2 negative, I think this is double bond oxygen, O negative, O negative. So you must know, you must able to draw the Lewis structure fastly, right? So then only you can quickly solve so many questions. Or you can go by the steric number formula. If you determine the steric number for this, it is coming to be 3. So S is equal to 1/2 times of carbon valence electrons are 4 plus monovalent atom 0, and there is 2 negative, you need to add that one. So 4 plus 2, 6/2. Steric number coming to be 3. So sp2 hybridization. Here carbon is sp2. Sigma, sigma, sigma. 3 sigma, no lone pair, sp2. Yes. Hybridization is due to the overlapping of atomic orbitals of same energy. Different energy is wrong, different energy is wrong. So none of the above kadu. Yes. If a molecule MX3 has a zero dipole moment, then see, I think you are not getting this right. Bonding orbital used by. So in this question, I think, see, it is not visible to you. I can see because very small letters, it's a typing error. See, the central metal atom hybridization. The central metal atom hybridization, so that the net bond dipole moment has to be 0. See, that is possible. See, there is MX3. So for the net dipole moment to be 0, it has to be trigonal planar, na? So consider X is more electronegative, then the net dipole moment will be like this. So this dipole moment, this dipole moment, this dipole moment, and the net dipole moment of these two, the resultant dipole moment of these two will be equal to this one, right? So this dipole moment is cancelled by this one. So the net dipole moment is 0. For this to happen, the hybridization must be sp2, right? See, with the same molecule, what happens if the same molecule is having this kind of hybrid, this kind of geometry? If it is having this kind of geometry, then what happens? The resultant dipole moment is not equal to 0, na? So sp2 hybridization gives that phenomena. Now, the linear structure is assumed by. The linear structure is assumed by. See, yes, this is linear, this is linear, this is also linear. We already draw this in the previous questions. We already drawn this in the previous questions, and this is try to draw the Lewis dot structure. C triple bond N O minus. This is also linear. Only SnCl2, Sn carbon, silicon, germanium, tin. So carbon is going to be the which family? Carbon from tin belongs to carbon family. So 1 2 3 4. So one chlorine, another chlorine. This is the lone pair. So because of this lone pair, bond pair repulsions, the bond angle is not. So the geometry is not linear, it is going to be angular. Hybridization of central atom is NF3. The hybridization of central atom in NF3. Again, NF3, S is equal to 1/2 times of valence electrons in nitrogen is 5 plus monovalent atoms is 3, 5 plus 3, 8/2, 4. If it is 4, sp3 hybridization, that's it. The pair having similar geometry, see, PCl3 and NH3, both are having tetrahedral geometry. CH4 and CCl4, tetrahedral. It is BeCl2 linear, H2O is angular, right? So IF5 and P, this is a trigonal bipyramid. What about IF5, iodine? Let me do for IF5. S is equal to 1/2 times of iodine valence electrons are 7 plus 5. Okay, so 7 plus 5. This is 12/2, 6. You are getting sp3 d2. hybridization is sp3d2, and pf5 we already know the hybridization is sp3d. So these two options are coming. See, in these two cases they are having same kind of shape, same kind of structure. Okay? Yes. See, both are having same kind of electron geometry, same kind of shape. Both are having same kind of shape and electron geometry, these two options. Next question number 102. The d orbital involved in sp3d hybridization. So I'll explain with an example. See, in the hybridization concept we discussed, in the case, let us discuss with an example of PCl5. The central atom is phosphorus and its valence shell is the third shell. So the valence shell is 3s, 3px, 3py, 3pz, and the d orbital is 3d xy, 3d yz, 3d zx, 3d x square y square, 3d z square. The point is, if you determine the hybridization for this, it is going to be sp3d hybridization. You already know how to determine this hybridization. Go by the formula. S is equal to 1/2 times of valence electrons plus monovalent. Okay, I'll do it. S is equal to 1/2 times of valence electrons in phosphorus is 5 plus monovalent atoms is 5. 5 plus 5, 10/2, 5. 5 means sp3d. That's okay. So sp3d hybridization suggests that the geometry is going to be trigonal, bipyramidal. So the central portion, this is the trigonal portion. This is the trigonal portion. Right? Yes. And what is really important here is, these trigonal corners, this is equatorial position, equatorial, axial and axial. These two are axial. So all the 5 corners are not same. These 3 are equatorial and these 2 are axial. So the hybrid orbitals, so before hybridization, the hybrid orbitals, you must keep in mind these kind of the difference, right? So these 3 are formed by these 3 hybrid orbitals are formed by the intermixing of 3 atomic orbitals. Which 3 atomic orbitals? See, this is trigonal planar on xy plane. So 3s and 3px, 3py. These 3 will intermix to give sp2, 3 sp2 hybrid orbitals. So one sp2, another sp2. Okay, and this 3pz, this pz, so this pz intermix with the dz square, z mix with the z to have 2. See, by the intermixing of 2 atomic orbitals, you will get 2 hybrid orbitals, 2 sp. So like that you are getting 5. So 3 sp2, 2 sp like this. So like this, these 2. So these 2 axial bonds or axial hybrid orbitals are formed by the intermixing of pz and dz square. So this is our answer. Okay. I hope you understand. Thank you.